We are talking about bisectors and triangles, medians and altitudes, and we want to identify and use perpendicular bisectors and angle bisectors and triangles, identify and use medians and altitudes and triangles. So we want to talk about a few things, and one of them is concurrent lines. Concurrent lines are three or more lines that intersect at a common point called the point of concurrency. So as we can see from this drawing, these three lines do not all meet at one point. These two lines meet, but they don't all meet at the same point. So this is not concurrent. Here we'd have the point of concurrency. And that is point P right there. So in our triangles, we'll have some lines where they all meet at one point. So one example of that is our centroid. And the centroid is the point of concurrency made from the intersection of the medians of a triangle. So we take all the medians of the triangle and they intersect, and where they intersect is called the centroid. The centroid theorem. The centroid of a triangle divides each median into two parts so that the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint of the opposite side. Okay, so what does that mean? That means that the distance from the centroid to the vertex, so let's look at, here's the centroid right here, the distance from P to B is 2 times whatever the length is from the centroid to the midpoint on the other side. So we're going to just call that one X. So an easy way to kind of remember this is, if we're looking at this line here, we can say BP is equal to 2x PL is equal to x. Well, if we were going to do our segment addition with these two, so BP plus PL, and that would be 3x. So BL is just these two added together. So BL would be equal to 3x. So we'll go through some examples later, but basically we're just going to label them as 2x, x, and 3x, and then solve from there. Another point to remember, the centroid is the center of gravity for any triangle. So here is just a stick right there, and there's the centroid, and this is demonstrating that the triangle is balanced perfectly and not tipping over on that stick as long as the stick hits on that centroid right there.